The law of conservation of energy states that energy isn't created or destroyed, it just changes forms from one form to another over and over. So, if we look at some toys like this clapper toy, we shake and stretch and make sound. We see that it has kinetic energy, stretches the rubber band, which is elastic potential, which then turns back into kinetic energy and makes sound over and over and over again. In the sun, we have nuclear potential energy that makes light energy, heat energy, and sound. Jumpy frog, we push kinetic energy down. It causes a spring to load and the suction cup into elastic potential, deforming, which then jumps for kinetic energy. Some energy is usually lost within the transfer because we have like one form wanting to go to another form, and then there's something that happens along the way where some energy is left in a non-useful form. So when we turn on a light, we want electricity to turn our light on. But the bulb gets hot, and so that energy as heat energy is lost within the system, and it's not going directly from the electricity to the light. So it's inefficient is what we call that. Here's some glow sticks where we have chemical potential energy stored, and we want them to turn to light energy. You can hear, though, that as I do them, they crack, and we consider that sound energy to be a loss in the system because we wish all the chemical potential would turn to light, but it does not. So looking back at our Jumpy Frog scenario, we can hear that sound, and so all our kinetic energy is not transferred to elastic and then kinetic. There is sound loss within that system. He's inefficient. Now, energy can be transferred from motion to motion. Like if you kick a soccer ball, the kinetic energy of your kick transfers to the kinetic energy of the soccer ball. Motion to motion. That's totally cool. You can also have motion to store to motion. So when you charge a battery, say in a flashlight, then you have electricity going in, motion energy, to store as chemical potential in the battery. That then would move to electrical energy back out into light energy in the light bulb. Notice that we're charging that battery and it has to go from motion to store back to a motion. What you cannot have is store to store. There must be some sort of movement to transfer from one store to another. Check out this toaster. We have electricity coming through the wall and we want it to turn into heat. But if you look, there's sound, we can listen, and they're light. And so toasters are very inefficient, like 30% efficient. In a car, we want the chemical potential energy of the fuel to turn into kinetic energy for our car moving down the road. The problem, though, is there's a bunch of heat loss because our car engine gets hot, and the engine also makes a bunch of noise. Like we know that the engine is running, we can hear it. And so all of that heat and sound loss make it so that our cars are only about 35% efficient as an engine, which is definitely disappointing. Can you describe the energy transfer going on in this speaker? Did you say electricity to kinetic to sound energy? Good job. The problem is that the kinetic energy is required to make the sound, and so only about 5% of the electricity in a speaker goes to sound, so they're terribly inefficient at their job. Can you describe the energy transfer chain going on in these chompers? For our chompers, we use kinetic energy to wind it up, and then elastic potential is stored within the spring inside of him. That elastic potential then will transfer into kinetic energy as he moves, but we have sound energy as he transfers into his kinetic motion, and then sound energy loss when we wind it up, which means he's a very inefficient toy. Can you describe the energy transfer when we drop this ball? Gravitational transfers to kinetic, transfers to a squishing or elastic potential at the bottom to kinetic, and then we have that sound loss as it's bouncing. Can you describe the energy transfer chain in this hemipolar motor? Well, this little device made of a battery, a magnet, and a piece of copper wire has chemical potential energy stored in the battery, which then transfers to electrical energy. This makes this move kinetic energy, and we have sound energy as loss. It also gets really hot in the process, so we have heat energy loss. So whenever you're analyzing an energy system, you always want to be aware that energy loss is occurring, like brakes on a bike, make sound, and get hot. And one of the points of engineering is typically to try to reduce the energy loss as much as possible so that we get energy going from one form to another as efficiently as possible so that we'd have to use less of it to get our work done.